In this video lesson, we will construct perpendicular and angle bisector with the use of triangle congruence. But first, let us define perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. When we say equidistant, meaning they have equal distance from each other. Using this illustration, in triangle ABC, what is BC if AB is equals to 10? If we will apply the perpendicular bisector theorem, BC is also 10. In triangle SUT, L is perpendicular to ST. What is SV? So looking at the figure, we can say that SV is equals to TV. And then we will just substitute the values. We have SB 2x minus 8 and TV x plus 5. And then we will use the left and the right side. We will collect all the terms with variables in the left side. So let's start with 2x. Do we need to transpose 2x? No, so we will just copy. How about negative 8? We need to transpose negative 8 to the right side, so it will become positive 8. How about x? X needs to be transposed in the left side, so from positive, it will become negative x. And then the last one, positive 5. Positive 5 is in the correct position, so we will just copy. Next, we will just combine like terms. 2x minus x is x, and then 8 plus 5 is 13. So the value of x here is 13. So we can now use the value of x to get the value of SV. SV is 2x minus 8. We will have SV is equals to copy 2, and then we already know that the value of x is 13. So we will just substitute, x will become 13. And then copy negative 8. SV is equals to 2 times 13, that is 26, copy minus 8, and then we will simplify. SV is equals to 18. So that is the value of SV. Let us now have the converse of the perpendicular bisector theorem. We will just interchange it. It means that if a point is equidistant from the endpoints of the segment, then it is perpendicular bisector of the segment. It is just the reverse of the perpendicular bisector theorem. Using this figure, in triangle LAS, OA is perpendicular to LS. What is OL if OS is 7? So as you can see, the two segments are congruent, and A is a perpendicular bisector, and the point A is at the perpendicular bisector, so OL is also 7. Let us have the proof 1. Given BD is perpendicular bisector of AC, using this figure, and then we need to prove that BA is congruent to BC. We will have the two-column proof. The first statement is BD is perpendicular bisector of AC. And then the reason will be given. Let us use the statement number 1, and then let us define perpendicular bisector. A line segment which intersects another line perpendicularly and divides it into two equal parts. So what are the two equal parts for AC? Looking at the AC, we have AD is congruent to CD. What is our reason? We define perpendicular bisector, so the reason is definition of perpendicular bisector. The next reason is definition of perpendicularity. First, let us define perpendicularity. These are the two lines intersect and they form 90 degrees or right angle with each other. So looking at the figure, what are the two right angles created? We have angle ADB and angle CDB, which are the right angles. Let's have the continuation. For the fourth reason, all right angles are congruent. So what are the two right angles which are congruent in this example? We have angle ADB is congruent to angle CDB. And then for the fifth reason, we have reflexive property, which side is being shared by both triangles. We have side BD is congruent to BD. And then for the sixth statement, we have triangle ADB is congruent to triangle CDB. For what reason? So we have SAS postulate. What is our last statement here? What will be the last statement? BA is congruent to BC using CP/CTC. Let's have proof number 2. Given CA is congruent to CD and CD is a perpendicular bisector of AB. This is the illustration. And then we need to prove that C is on the perpendicular bisector of AB. We need to prove that the point C is located at the perpendicular bisector. Let's have the two-column proof. The first statement will be CA is congruent to CB, and then the reason will be given. For the second reason, we also have the given. What is our statement? It is CD is a perpendicular bisector of AB. For the third reason, we have definition of perpendicularity. We already defined perpendicularity a while ago. So what are the two right angles created here? We have angles ADC and angle BDC, which are the right angles. For the fourth reason, we have all right angles are congruent. So what are the two congruent angles? Angle ADC is congruent to angle BDC. For the next one, we have the fifth reason, which is reflexive property. Which side is being shared by both triangles? We have side CD congruent to side CD. And then for the sixth statement, we have triangle ADC is congruent to triangle BDC. Since looking at the figure, we have two sides and an angle, and we don't have side-side angle postulate, we can now use the theorems for right triangles. What is the theorem being used here? We have the hypotenuse leg theorem. And then for the seventh reason, we have AD is congruent to BD because of CP/CTC, because they are corresponding parts. And then for the eighth statement, which is our last statement, we have C is on the perpendicular bisector of AB. The reason will be definition of perpendicular bisector, since the segments are equidistant from each other. Let us now have the angle bisector. What do we mean by angle bisector? A segment, ray, or line that divides angle into two congruent angles. In this figure, in triangle DAB, segment AC is the angle bisector. If AC is the angle bisector, what are the two congruent angles created? We have angle DAC is congruent to angle BAC. If the measurement of angle DAC is 50 degrees, what is the measurement of angle BAC? The measurement of angle BAC is also 50 degrees. How about in this figure? In angle QSP, angle QPR is congruent to angle SPR. Let us find x. What is the value of x in the figure? X is equals to 40 degrees because of angle bisector. How about this one? In triangle SIR, angle 1 is congruent to angle 2. If angle 1 is 2x and angle 2 is 50 degrees, what is the value of x? So we already know that angle 1 is congruent to angle 2. So we will just equate them. So we have angle 1, which is 2x, equals angle 2, which is 50 degrees. And then we need to divide both sides by 2 to get the value of x. 2x divided by 2, it is x. And then 50 degrees divided by 2, it is 25 degrees. So the value of x is 25 degrees. In triangle MAT, angle MAH is congruent to angle TAH. If the measurement of angle MAH is 2x plus 5 degrees and the measurement of angle TAH is x plus 25 degrees, what is the value of x? Using the angle bisector, we already know that these two angles are congruent. So we have the measurement of angle MAH is equals to the measurement of angle TAH. MAH is 2x plus 5 and TAH is x plus 25. So we will use the left and the right side. We will place all the terms with the variable in the left side. Let's start with 2x. We will just copy 2x. It is in the correct position. How about 5? We need to transpose positive 5 to the right side, so it will become negative 5. And then the next one, we have x. How about x? Do we need to transpose x? Yes. So that is negative x. And then we have positive 25. So we will just copy positive 25. Afterwards, we will combine like terms. We have 2x minus x, that is x. And then negative 5 plus 25, unlike sign, minus, copy the sign of the bigger number. So we have 20. We already now have the value of x, which is 20. Let us now find the measurement of angle MAH. We know that the measurement of MAH is 2x plus 5. So we will copy 2. And then the value of x is 20. So we will just substitute. And then plus 5. The measurement of angle MAH is 2 times 20. That is 40. And then plus 5. The measurement of the angle is 45 degrees. How about the measurement of TAH? We have x will become 20, so we will just substitute, and then plus 25. The measurement of TAH is also 45 degrees. Since we already have the measurement of the two angles, we can now have the measurement of angle TAM, the whole angle. So we will just add the measurement of MAH and the measurement of TAH to get the measurement of TAM. We already know that both angles are 45 degrees. So the measurement of angle TAM is 90 degrees. Let us have the proof number 3. Given LO is congruent to VO and angle LOE is congruent to angle VOE using this illustration. And then we need to prove that OE bisects angle LEV. We will have the two-column proof. The first statement is LO is congruent to VO. What is the reason? The reason is the word given. The second reason is also given, so the statement will be angle LOE is congruent to angle VOE. For the third statement, we have OE is congruent to OE. For what reason? For reflexive property. And then for the fourth statement and fourth reason, they are both given. We have triangle LOE is congruent to triangle VEO because of SAS postulate. For the fifth reason, we have CPCTC. What are the two angles created because of the OE? We have angle LEO and angle VEO. They are both congruent because they are corresponding parts of congruent triangles. And then for the sixth reason, if a ray divides an angle into two congruent angles, then it bisects the angle. So we can now prove our last statement, which is OE bisects angle LEV. So that's how we prove the perpendicular bisector and angle bisector using the triangle congruence.